Okay. Scientists think that variables x and y are related by an equation of the form y equals a times x to the power n. She collects the data and plots a scatter graph with log of x to the base 10 on the horizontal axis and log of y to the base 10 on the vertical axis. The points follow a straight line with gradient 2.6 and intercept minus 0.9. Find the values of a and n and hence write an equation for y in terms of x. So you need, the question's asking you to find the equation for y in terms of x. So you are going to find a value of a and a value of n. Right. So if we can just have a little look at how we would answer that. So, first of all, it's kind of nice to visualise what your straight line would actually look like. So if I had a straight line and I've got the log of x to the base 10 and I've got the log of y to the base 10. And I know I've got a straight line and it's got a positive gradient, whoops, it's got a positive gradient and a negative intercept. So I know that that's my negative intercept there and that's minus 0.9. So if I take the value that the equation that I've got there, what I'm going to do is I'm going to take logs to base 10 of both sides. So I'm going to have the log of y equals the log of this product. You know from your first law of logs that the log of b is the log of a plus the log of b. So I'm now going to split that up. So the log of y is the log of a to the base 10 plus the log of x to the power n of the base 10. Because it's logs to base 10, I don't have to put my base in. I can just use log. Law 3 of logs, I know that that power can come down and I can rewrite that as the log of y is the log of a plus n times the log of x. And it might even be more helpful to rewrite that is n times the log of x plus the log of a. So what I've now got there is something that I can compare in my straight line form. So if I think about what my straight line really looks at, think of that as like capital Y, and I've got my gradient. So I'm just trying to distinguish from like the little lowercase x and the lowercase y that I've got there. I know that my gradient is 2.6. So I know that the gradient I've got here is 2.6. So I can instantly say that n is 2.6 without much work at all. And I know that my intercept is the log of a to the base 10. And remember from the question, you were told that your intercept was negative 0.9. So what I'm going to do is I'm going to let the log of a equal minus 0.9. Now, I now need to write that in index form, and we've got varieties of ways we can do it. We've got a choice of methods, and I'll show you both. One way would be to think that that's the log of a to the base 10. Actually write the base 10 in. And you could then rewrite that. Remember, if and only if. Your base is 10. Your log or power is minus 0.9, and that equals a. So to 3 significant figures, putting that in your calculator, a is 0.126. Some of you might prefer to do a different method, just as you would unlog a natural log by making it power of e, you could unlog a log to base 10 by making it a power of 10. Just attempt that again. Yeah, not working. So what you could do is you could just make that power of 10. And 10 to the log, any log to base 10 is just itself. Just in the same way as your natural log works. I think I would prefer the first method. That makes maybe more sense to me. But whatever you do, you found A as 0.126. And then the question asks you to put that back together. So you know that Y is A, so 0.126 x to the n. So you have answered that first question. Second question. So if I just zoom in on this so it's a bit easier for you to see. Okay. Second question, it says a scientist is modelling exponential decay of the amount of substance in a chemical reaction. She proposes a model of the form m equals k times c to the power t. So your variables are that capital M and that little lowercase t there, where m is the mass of the substance in grams and t is the time in seconds since the start of the reaction. And k and c are constants, okay? We're going to have to find k and c. The mass of the substance is recorded for the first 6 seconds of the reaction. The graph of ln m against t is shown. So if you can have a little look at the graph here, I'll zoom out a bit so you can see it. So you can see that they've got a straight line graph there, straight line graph, and ln m is on the vertical axis and t is on the horizontal. I'm just going to zoom back in. They have plotted a couple of points for you on the straight line. So they've plotted a couple of points. So you can see it's going to be very easy for you to find the equation of that straight line. So let's have a little look at how we would do this question. It is asking quite a lot. So the first question is asking the points, whoa, it's a really dodgy shadow there. The points found on a straight line, find an equation, find the equation of that straight line, giving parameters to 2 significant figures. So it's specifying it wants the equation of the straight line and everything to be given to 2 significant figures. Right, first of all, so we've got t against the natural log of m. All I'm going to do for the first part, so part A, my 2 points on that line, if I can make it a little bit clearer for you, are 1.83, and the other point is 6, 1.02. So very straightforward. It's just my line isn't y and x. My line is ln m and t. So that's what I'm going to use. So first of all, my gradient. So my gradient is going to be the change in y over the change in x. So this is quite straightforward to us. I'm going to do 1.02 take away 1.83 all over 6 take away 1. So my gradient is minus 0.16. My gradient is minus 0.16. And now what I'm going to do is I'm going to find the equation of the line. So for a minute, I'm going to use y equals mx plus c, and then I'm going to convert it back to ln m and t. So I know y minus y1 equals m x minus x1. So I'm just going to use y and x because I find it easier. I'm going to use the point 1.83 is my point. So I'm going to get y minus 1.83 equals minus 0.162. I'm going to use the more exact one while I'm working out. You don't have to because they have told you you can use 2 significant figures. So I'm going to substitute that in, and what will happen is when I multiply and sort that out, I'm going to get y equals minus 0.16x to two significant figures, and then to two significant figures, that's going to be plus 1.99, or a roughly 2. So that's the equation of the line, but I am now going to put the correct parameters back in. That's what it wants. That's ln m on my vertical, and this was t. So that's my answer to the first part. Part B. Now part B wants me to find capital K and C. And if we remember from the beginning of the question, you had part B, we've got M equals K C to the power T. So that's what we've got. Now what I'm now going to do is I'm going to take logs of both sides. So again, from the question I can see I'm using natural logs. So I take the natural logs of both sides. Again, I'm going to split that product up. So I'm going to have ln m equals ln k plus ln c to the power t. Just as before, I'm going to get ln m equals ln k plus t times ln c. Now we know that ln m is on our vertical axes and t is on our horizontal axes. So we know, if we rearrange it, it's probably easier to see, that the gradient of our line is ln c and our intercept is ln k. We're now going to compare this with the line that we worked out in part A. So we got ln m is minus 0.16 t plus, what was our constant? If we have a quick look back, 1.99. So all you're now going to do is you are going to compare your coefficients. ln c is minus 0.16. If ln c is minus 0.16, you know you can undo the ln by making it a power of c, or you can rewrite it in index form. So c is e to the minus 0.16. I'm going to leave it like that. And I can also see that ln k equals 1.99. Approximately 2. So if I make those both powers of e, I'm going to get k equals e to the 1.99. And I'm going to substitute that into my calculator, and I'm going to get roughly 7.33. So I'm now going to substitute those back into the equation I was given originally. M equals 7.33 e to the minus 0.16 to the power t. So I've replaced k and c in my original equation. So m equals 7.33 e to the minus 0.16 t. There's a part C, which is a really good question, and it reminds us about logs and inequalities, how we've got to totally respect them. So if we go back to this last question here, part C, I'll read it to you. How long to the nearest second will it take for the mass of the substance to fall below 1 gram? So what they're wanting you to find here is they want the mass to be less than 1 gram. And you're going to find the value of t in seconds. So when m is less than 1, they're asking you to find t. So this is part C. You take that equation, you're going to take that equation, So 7.33 e to the minus 0.16 t is less than 1. So you're going to use that. What you're going to do is, the first thing, you're going to divide both sides by 7.33. Now I know that 7.33 is positive, so I have no worries about inverting my inequality when I divide by a positive value. I'm now going to take natural logs of both sides. That's because I need that power to come down. I'm going to take natural logs of both sides. Okay, using the laws of logs, my power will come down. Okay, we know that the natural log of e is 1. And here, I know that I need to divide by negative 0.16. Now, when I multiply or divide an inequality by a negative value, I invert the inequality. So t is going to be greater than, and I'm dividing by negative 0.16, which is obviously the same as multiplying by the reciprocal of it. I'm going to put that in my calculator, and I'm getting t is greater than 12.3, 12.4 seconds. Now if you go back to the question, it asked you to find the nearest second. We know that if time this has to be greater than 12.3, we are looking at 13 seconds.